Man, don't turn my phone off. Don't do that.
So you think they f with your phone?
Oh, I'm sure of it.
My computer just froze again is what I'm trying to say. Something freaked out my computer. What I can see on that screen is not what I can see on my computer screen.
I assume they listen to everything I say.
They do.
Every time I'm shrinking in this video, it's just like, it doesn't like to do this.
Huh.
I don't know what's going on. I have no control over the computer. Alt-Tab does nothing, Escape does nothing.
Yo.
Spacebar does nothing.
This is kind of funny.
Has this ever happened to y'all before?
No.
You know what's going on.
Terrence Howard is suggesting a different way of looking at the periodic table of elements. He believes the current periodic table doesn't show the true relationships between elements. For example, hydrogen is often shown alone, but he thinks it shares similar properties or tones with elements like carbon. By tone, he means a specific frequency or vibration. For instance, he compares the vibrations of elements to musical notes or frequencies. Hydrogen vibrate at 40.5 Hz, carbon at 81 Hz, silicon at 162 Hz, and so on. These vibrations or tones can be related to both sound and color as they follow similar patterns of wavelength. He references Walter Russell's periodic table, which he feels shows these relationships better than the traditional one by Mendeleev.
Walter Russell's periodic table that he put together. Now you compare that to what Mendeleev's periodic table. You'll compare Walter Russell's to it, and you'll see something completely different. It's unwinding.
Whoa.
It's unwinding. You'll see there's a relationship between hydrogen, carbon, silicon, cobalt, rhodium. They're all bonded. They're all sit as the middle point between two noble gases.
According to Howard, elements like hydrogen, carbon, silicon, and cobalt have specific relationships and act as central points between noble gases. Howard suggests that all matter is fundamentally connected, implying that what we perceive as different elements might actually be variations of one underlying substance. He notes that hydrogen is the first element we can see because anything denser isn't visible to us. When moving to carbon, he mentions it has a balance of positive and negative properties, making it unique.
As you reach into the next octave, the carbon octave, and they call that a bisexual tone because the carbon has two tones to it. It has a negative side and a positive side. The part where lithium behaves, lithium is contractive. Beryllium is contractive. Boron is contractive, but the moment you get to carbon, you balance it out. It gets to a perfect balance, a plus and minus 4. So it's a double tone.
He also explains how certain elements naturally bond or react with each other. For example, fluorine will always bond with lithium, breaking any existing bonds to do so. Similarly, introducing beryllium to water will cause oxygen to bond with beryllium, splitting water into hydrogen and oxygen. By using frequencies, you can separate hydrogen and oxygen from water without the usual methods like electrolysis or heat. For example, hydrogen, being smaller, would go into one tube and oxygen into another, simply by using the right frequency. He provides an example with sodium and chlorine. When you rub salt, sodium, on your skin after swimming in a chlorinated pool, it neutralizes the chlorine, turning it into an oil. This demonstrates how everything has an equal and opposite mate. Howard also explains that elements can transform as they move up in frequency or octaves. For instance, lithium becomes sodium in the next octave, and sodium becomes potassium in the following octave. These transformations follow a pattern where each element doubles in frequency and becomes wider.
The reason that arsenic kills us is because our DNA has nitrogen and it has phosphorus in it, because nitrogen unwinds into the next octave right after silicon and becomes phosphorus. Our DNA has both of those in there, but it's going by tone. So the moment arsenic, which sits as a -3 on the next octave, the moment arsenic is introduced, the body thinks that, oh, this is my thing that I need, and it tries to wrap itself around the arsenic, but it causes the DNA to unravel because it's 4 times as large as that nitrogen was.
Howard talks about various elements like titanium, vanadium, chromium, magnesium, and iron, which he refers to as isotopes rather than true elements. He compares these elements to wrapping a rag around your hand. The more you wrap, the more distinct each layer becomes. With the right understanding of wave frequencies, we can now unravel these elements in ways that weren't possible before.
The angles of incidence that were necessary to open these things up. And you couldn't do that with the platonic solids because the platonic solids were averages and approximations.
The old models, like the platonic solids, were too simplistic because they didn't account for the natural curvature of motion. He emphasizes that all motion in the universe is expressed in waves which are curved, not straight. Howard also talks about the balance of forces in the universe. Every action has an equal and opposite reaction, and this balance leads to the curvature in motion. He critiques Einstein's theory of relativity for not including this balancing force. He explains that gravity is caused by electric forces, which always seek higher pressure and move in a spiral pattern. These forces eventually convert back into the electric field and return to their source.
What happens when we get older? We expand at our equator, right? We get shorter at the top. Why? Because the electric force is pushing in and condensing, and the magnetism expands out at the equator.
Electricity for the Earth works in cycles, pushing itself back out at the equator, making the equator 5 miles wider than the poles. Einstein's equations didn't separate electricity and magnetism properly. He saw them as coupled forces, but in reality, they are opposites. Electricity is like breathing in, a contracting force, while magnetism is like breathing out, an expanding, radiative force. The term magnet suggests attraction, but to magnify means to make something larger, which is the work of radiation. This idea aligns with what Walter Russell talked about years ago. Russell emphasized that radiation works to increase space, while electricity pulls things together. Traditional science teaches that opposites attract, like hot and cold air or water, but in reality they move in opposite directions. 2 magnets, for instance, seem to attract because of the way they align, similar to how 2 streams of water would push against each other but eventually align. Howard suggests we've been misled by our senses, particularly our vision, which sees only a tiny fraction of the electromagnetic spectrum. This limited view has caused science to misinterpret many things. For example, E equals mc squared only talks about expansion, not contraction. We never breathe in twice without breathing out. This natural balance of in and out, charge and discharge, is missing from scientific models that focus solely on expansion, as influenced by Newton's idea that everything moves in a straight line unless acted upon. Newton's ideas have led to a 2-dimensional understanding of space, which fails to account for nature's inherent curvature. This misinterpretation extends to the periodic table, where elements are seen as isolated and static rather than interconnected and dynamic. Conventional science sees carbon as always being carbon, but Howard suggests that it actually unwinds and transforms into nitrogen and nitrogen into oxygen. Walter Russell's version of the periodic table addresses these interconnections and transformations, showing elements as part of a continuous process. However, those who study the conventional periodic table often overlook or dismiss Russell's ideas, not fully understanding the dynamic nature he proposed.
Remember the Michelson-Morley experiment from 1887? They were trying to prove whether there was an ether or an effect of an ether, or the quintessence that everything came from. That used to be called the fifth element. From antiquity, everyone understood that something doesn't come out of nothing. It's like when you look at the air, it looks clear, but you change the pressure condition. The balance of the change of pressure condition, we call that condensation. It creates clouds. And you change the motion conditions, whether it's moving quickly or slowly, it's going to become snow, it's going to become rain, it's going to become hell.
Howard argues that everything boils down to 2 forces. Either you're filling up something, breathing in, or pouring it out, breathing out. He criticizes scientists for ignoring Walter Russell's work because Russell didn't use mathematical equations. Instead, Russell approached these ideas philosophically, discussing how things behave rather than strictly adhering to Newtonian physics or calculus. He criticizes scientific methods like the Feynman diagrams, which he sees as overly complex and contrived, suggesting that they eliminate possibilities until only one answer remains, a method he believes is flawed. He points out issues with probability and concepts like the Heisenberg uncertainty principle and Schrödinger's cat, arguing that they stem from removing the concept of ether. According to Howard, electromagnetic waves need a medium, and effects cannot exist without a cause, like the chicken and egg scenario. Howard mentions Dr. David Tong from Cambridge, who stated that much of what is taught in physics is incorrect because it overlooks the true nature of how things work. This includes the results of the Michelson-Morley experiment, which assumed a stationary ether. However, Joseph Larmor proposed a moving ether with opposing vortices, aligning more closely with Walter Russell's views that the Sun gave birth to the Earth rather than the Earth forming from a coalesced field. Howard also highlights that the Earth is drifting away from the Sun by about 0.6 inches a year, a phenomenon observed universally as planets in solar systems drift away from their primaries at a consistent rate. This suggests a universal expansion. Recent observations like those from the Webb telescope challenge the traditional timeline of galaxy formation, supporting the idea that our current understanding of the universe's age and formation might be flawed. By calculating the drift of the Earth away from the Sun, he points out that it would take about 105,600 years for the Earth to move just 1 mile. This slow, steady drift challenges the conventional view of a static universe, reinforcing the idea of continuous movement and expansion. To understand how long it would take the Earth to reach its current distance from the Sun, 93 million miles, at a drift rate of 0.6 inches per year, it would require approximately 9.8 trillion years. Similarly, for Mars, which is 147 million miles away from the Sun, it would take about 15.8 trillion years to reach its current position.
So at a given point, Mars was here in the Goldilocks zone. And now Venus is going to inherit the Goldilocks zone next. They forget that Mercury is under the highest pressure possible. So it can expand. It's like hydrogen. It's like those octaves before hydrogen. So the atmosphere, the iron isn't able to release any oxygen and the oxides. But when you get to 67 million miles away from the Sun, the pressure is a little less, but it's still so much higher than the pressure on Earth.
This is comparable to being deep inside the Earth, where the pressure is immense. Venus, which has thick clouds filled with sulfur and ammonia, will eventually move into a position where conditions might become more Earth-like. In the future, as Earth moves to where Mars is now, Venus will take Earth's current position, possibly in 5 or 6 trillion years. When this happens, life, including humanoids, might develop on Venus, similar to how it developed on Earth.
That asteroid belt that we have right now between Mars and Jupiter, that used to be a planet. And I believe that they had humanoids that developed on there.
This concept is tied to the periodic table because the table represents not just the elements but also the periodic nature of these changes. Elements transform based on changes in motion and pressure conditions. What we call different elements are essentially the same substances behaving differently under varied conditions. For example, if you move your hand in different ways, it might look different each time, but it's still the same hand. Similarly, elements appear different due to changes in their environmental conditions, but they are fundamentally the same substance. As you saw at the beginning of the video, something strange happened when they tried to play a very important video in which Terrence demonstrates how planets can be created. Terrence and his team used a simulator from Princeton to conduct the experiment. In this experiment, they arranged shapes called Lynchpins, where 6 pentagons meet in a specific order. Let's watch the video. Pay close attention, please.
Before we watch it, let me explain something. If you were to picture the waves at the ocean, you know, the darker the waves, the deeper the water, you can't see a distinguishing fact between them until they crash into each other. That splatter, that little foam that comes out, it lasts for a couple seconds, and then it settles back on there, and it's just the balance between this force and this force. That's the physical universe. Those few seconds that it takes that matter, that more dense water, and the foam to recoalesce and get balanced again with the surrounding environment. That's the entire time that our universe, or all these universes, have worked together.
Okay, so this toroid is just there for a geometrical reference. It's not actually doing anything. It just kind of symbolically represents a magnetic field. Now on the right-hand side of the model here, I have two groups of vortexes, which are just like tornadoes, spinning tornadoes that are pointing towards the center. As I highlight this object here, you'll see it, that yellow line, right? So there's a bunch of those in there. There's actually 16 of them, and I'll highlight them all. There. And I'll render that just so you can kind of see a little bit better. So they're all pointed towards the center, but they're arranged in what we call the Lynchpin configuration. I'm going to pretend like you never heard of that before. So there's one on the top, and then three, in groups of three around, that are spaced at 120 degrees apart, and the tilt of these ones on the bottom here is 109.5 degrees in relationship to the top ones that are creating this flat space on the top and the bottom. And they're spaced at 120 degrees radially. And then inside the model is three groups of particle systems with known masses up to 1,000 pounds, from 2.2 pounds to 1,000 pounds. And there's no gravity whatsoever in this model. There's no center attractor. So it's just vortexes and two magnetic fields, a north and a south polarity, and one harmonic resonance, which is emanating a vibration in the field in this region here where these vortexes are pointed. So it kind of just oscillates to give it a little bit of randomness in motion so that the particles will kind of interact and bounce around like smoke or water, waves and water. And then when I hit play, it does it all by itself using physics simulations. So there's no animations at all in this model. And when I play it, this is what pops out.
Wow.
And then when I look down at the top, it makes the actual hexagon that NASA has observed on the top of Saturn.
Without gravity.
Without any gravity. And you'll see that you get a surface of the sphere on the inside with the heavier particles. So the colors...
Are you basically saying, is this saying that you guys can recreate planets?
Yes, this is a particle simulation of the physics involved in making up the planet Saturn.
Terrence Howard is explaining that by changing certain angles in their calculations, they were able to recreate the exact form of Saturn, including its rings, without relying on gravity, dark matter, or dark energy. This was achieved by adjusting the angles at which linchpins, configured with opposing vortices, interact. These adjustments change the motion and pressure conditions, affecting how elements form or crystallize. He ties this idea back to the periodic table, suggesting that with the correct angles of incidence, we can now manipulate materials at a fundamental level. This allows for the creation of new materials like transparent aluminium by controlling the space between elements like carbon, nitrogen, and boron, and working with elements like titanium, vanadium, and chromium. Howard criticizes the traditional Cartesian and Euclidean models, which use straight lines and 90-degree angles, as inadequate. He suggests that nature operates with more complex, curved interactions similar to how bubbles meet and form shapes. This idea is illustrated by dropping a pebble into water, where the waves expand in spheres and interact, creating geometric patterns when they meet. He argues that the universe must be finite because the waves that create shapes would only return if they bounced off an edge. This concept challenges the idea of an infinite universe. Howard believes his method of calculating angles and pressures can predict the arrangement of stars in the Milky Way better than current models used by NASA without relying on dark matter or dark energy. Howard then critiques the theoretical nature of dark matter and dark energy, pointing out that they have never been observed directly. He references the Michelson-Morley experiment from 1887, which tried to detect the ether, a supposed medium through which light travels, but found no effect, leading scientists to assume ether didn't exist. This assumption led to the development of particle physics and Einstein's theory of relativity, which dismissed the ether. Howard mentions that earlier physicists like Lorentz and Maxwell still considered the ether in their theories, but were limited by Newtonian laws. The shift away from considering the ether led to the theoretical focus of modern particle physics, which Howard believes has led science down an incorrect path for the past century. Terrence Howard explains his theory of planetary formation by comparing it to biological processes. Just as living organisms discharge waste, he suggests that stars, like our Sun, eject matter, which eventually forms planets. He uses Jupiter as an example. The Great Red Spot on Jupiter, a massive storm, is seen as an area where the planet is discharging matter. Over the course of 1 to 2 billion years, this matter could become a moon. This discharge happens at the planet's equator, similar to how living organisms discharge waste at their midpoint. This ejected matter then orbits and is gradually pushed further out by forces such as solar wind. Howard likens this to coronal mass ejections, CMEs, from the Sun, where the Sun ejects plasma into space. Over time, this ejected matter gains distance from the Sun and can start forming new celestial bodies. For instance, Mercury, being close to the Sun, represents an early stage in this process. As time progresses, more planets are formed and pushed outward, creating a dynamic and slowly expanding solar system. This process occurs so slowly that it appears static to us, similar to how plants appear stationary even though they're constantly growing and moving. Using time-lapse photography, we can see plants moving and interacting, but this movement happens at a pace that our brains typically cannot perceive. Howard suggests that planetary formation happens on a similar time scale that our minds struggle to comprehend. In this view, the Sun is continuously creating new planets, but it happens over such long periods that it seems static from our perspective. This means that while we observe the solar system as stable, it is actually in a constant state of slow evolution.
Gravity is supposed to be the greater the mass is the greater the attractor. You take a balloon, you rub it on your leg, you put it over the ground. Watch the dust particles jump off the ground, off this big mass called the Earth, and jump onto that balloon. Because why? Electricity is 137 times stronger than the pull of gravity or the effects of the so-called gravity. It's the electric force that's the attractive force. It's the electric force that tightens everything together.
The electric force is the attractive force that pulls things together, acting like a masculine force. On the other hand, the radiative force, or magnetic field, pushes things outward, causing expansion. These forces work together in a cycle of contraction and expansion. When these forces meet at specific angles, like the Birkeland currents, which are plasma currents in space, they can convert magnetic energy back into electricity. This process of contraction and expansion continues, contributing to the formation and sustenance of life and matter. Howard suggests that planets are not just lifeless objects, but are alive and dynamic, created and maintained by these forces. Howard criticizes the concept of gravity, suggesting that what we perceive as gravity is actually the effect of the electric field created by the Earth's spin. When a Saturn V rocket escapes Earth's atmosphere, it is fighting against this centripetal inward spin and the associated electric field, not gravity as traditionally understood. Gravity, in Howard's view, is the effect of the electric field, which is balanced by the radiative magnetic field. The more mass an object has, the greater its electric potential, meaning the electric field becomes stronger, pulling things together more tightly. Howard describes two fundamental directions in the universe: spinning to the right, northeastern direction, which he associates with electric forces, spinning to the left, southwestern direction, associated with magnetic forces and expansion. When elements are close together, the electric force can act without interference from the magnetic field, allowing things to remain tightly bound. If they move apart, the magnetic field causes them to expand and separate.
If you're right, so many people are wrong.
Everyone's wrong. Oh, well, the universe backs me up, and I have the proof of it. You have all these physicists that's saying something different, but none of them have 97 patents. None of them have introduced a new form of flight with unlimited mid-air bonding. None of them have discovered 4 supersymmetrical systems. There's no government on this planet that has the technology that I have or can outdo what I have, because you can't outdo the fractal.
Terrence Howard is explaining that the way we currently do math and understand the universe is limited because it's based on 2-dimensional thinking. He believes the universe actually operates in 3 dimensions, or volumetrically. Instead of just moving in straight lines or flat planes, everything in the universe moves and interacts in all directions. In practical terms, think about a computer chip. Traditional designs make electricity move in straight lines and 90-degree angles. This causes a lot of friction and heat because the electricity has to constantly stop and change direction. Howard suggests that if we design these chips to follow natural curved paths like spirals or spheres, the electricity would flow more smoothly, without generating as much heat or losing energy. This idea is based on how he believes the universe naturally operates. He criticizes traditional math and physics for not considering the constant motion and interaction of everything in the universe. Instead of reducing complex actions to simple, straight-line equations, we should look at the bigger picture and consider all the forces at play. Howard also points out that what we perceive as straight lines aren't truly straight. Even at the microscopic level, everything is made up of tiny curves. He believes that to really understand the universe, we need to think in terms of 3 dimensions and include our perspective as a 4th dimension. This approach, he suggests, can lead to more accurate and efficient technologies and a better understanding of how the universe works. Our perception of straight lines and squares is an illusion. For example, when we look at something straight on, we might see a square. But if we change our perspective and look at it from the side, we realize it's not actually straight. Our senses deceive us into thinking straight lines exist, but in reality, everything moves in curves. He uses the example of homes to illustrate this point. Modern homes are built with straight lines and flat surfaces. However, in hurricane and tornado-prone areas, these homes are easily destroyed. Howard suggests that if we build homes following the natural curves found in nature, like the shape of a mushroom, they would be more resilient. The curved design would allow wind to flow over the structure, reducing damage from extreme weather. Similarly, airplanes are not designed as simple straight boxes. They're aerodynamic, with curved surfaces to allow for smoother, more efficient movement through the air. By moving away from straight-line designs, engineers have created more effective and resilient structures. Howard's main point is that by understanding and mimicking the natural curves and motions of the universe, we can create more durable and efficient designs. Straight lines and flat surfaces are not natural, and by continuing to use them, we're making things more difficult for ourselves. Instead, we should embrace the natural curves and motions that exist all around us.